All right. Hi. So this is Mohammed Siddiq, and this is my official recording for the submission of homework two. And yeah, finally I'm here. So before I begin with, this is my account. I'd want to show this. So here's my name on the account, and this is my official account. So well, just to show that I have not got any credits into my account. So anyways, I'll be just demonstrating a job that I'll be running on the EMR instance right over here. So before I do that, I'd want to set up the S3 bucket where I would have my jar as well as my data corresponding. Right, so this is my S3 bucket. I'd want to put the jar in it. So CMD, let's put things there in the downloads. DBLPXML will be going into slash, I guess there's an input folder that I just created. This is my S3 bucket, and this is my input folder that I've created inside that. So let me just add it into input. All right. No such option. Oh, what's the issue? Yep, so this must be uploading the file onto the S3. While it does that, let me build my jar right from here. spt clean. So let me check. So it requires yep. So let me get the jar and let me put the jar onto the cloud as well. It's uploading. So just to give you a walkthrough while it is happening, I have my job runner. That is the main driver class of the Hadoop MapReduce. So here it's pretty straightforward. I'm defining the configurations for the file. So I'll be loading the input format. That is the configs that are there over here. Alright, so I'll be loading the start tag. So this is the start tag and this is the end tags that I've defined. And so I'm specifying the start tags and the end tags in the configuration, and I've implemented my own version of the XML input format that would support the multiple start tags as well as the end tags to parse the file. And I've given my instance of the mapper over here, which essentially generates the mapping among the authors and the corresponding weights that are associated with the authors. So essentially, let's say if the authors are from UIC, it produces an basically a mapping between those authors, saying that author A1 and A2 have worked together, A1 and A3 also have worked together, A2 and A3 have worked together, likewise A3 and A2. So for the authors that are there in a paper, let's say they are A1, A2, A3, so these mappings would be produced by the mapper. Thereby the reducer would just straightforward implementation where it will just add the values of the mappers output and then just write it onto the file. So essentially it's just the addition of the values that is given by the mapper, right? Okay, let's go. I think this, okay, it's just progressing at 62%. Let's do spt build, spt assembly, right? So while it is doing so here's the situation right now. So what I'd be doing is I'd be running an instance of cluster, and I'd be creating a cluster over here with the defaults essentially, and I would be providing, well, rather I'll create a logs folder. Let me just create a new folder in my S3. The new folder called logs, where all the logs of my map reduce would go into it, right? And well, it's just compiling all the three files. So let's wait for it to happen. So what I'd be doing is after running the job, I would have written this small piece of code using graph visualization that would eventually that essentially produce a graphical visualization of the entire output that is given by the mapper, or rather the MapReduce job, and it would produce dot notation of the files of the output, and eventually giving the graph, sorry, in the PNG file. So I demonstrate the entire visualization as well. Okay, it's probably taking a while. So it's part 10 of 10.161. Okay, it's gonna take a while for it to upload. So I might pause the video for now till it does that, so that I will be able to demonstrate the so the build is ready. So I'm going to upload this x3 cm3. So this is put target slash come on Scala, essentially Scala slash, this is my chart, Muhammad Sadiq XW3, and that would go into my default S3 bucket, which happens to be this, right? I'm pushing it there. Let's go. And the upload is begun. So I'm going to pause the video for now. I'll wait for these uploads to happen onto the S3, post which I'll be demonstrating the MapReduce and the Amazon EMR, and yeah, we'll take it from there post that. All right, so the files are copied onto the S3 bucket now. So let me just check. Let me check into the directory. So these are the loggings that just happened. So I've had enabled logging for every operation that happens on the S3. So ignore these files. So I've copied into input currently. So let me check into the input directory. And look, here's the jar that I created. And so S3 cmd ls, the input directory. Oh, just copied the jar. S3 cmd ls. And here is my input directory, right? And there you go. As you can see, this is the dblp xml file that is the actual input to the MapReduce. So it's copied onto the input folder, right? So I'll be providing this path as my input. All right. And the jar is already there on S3, so I just have to create a cluster on EMR, and let's see. So let me start from scratch. Go into EMR, create a new cluster, and I'll go to advanced option, and I'll go with the defaults for now. I'm gonna select a custom jar, configure it to my jar that I just copied. Oh, this is the jar of mine. All right, and I'm gonna name this jar as my demo jar. Okay, and the path and the arguments for the algorithm, or rather the mapper is job, would be my package name, which is, let me go to the code, relate authors dot job runner. All right, so it would be the jar location, this thing. It would be relate authors dot job runner, followed by my input path, which is this, the input directory on the S3, followed by an output path, which is, I'm gonna create a new folder right over there, and this would be my output file. All right, okay, so I've got this, and I have got this as my output file. Cool. And action and failure, if at all it fails, I'm going to terminate the cluster just to be on the safer side, and the jar location is given. Cool. So I'm going to add the cluster, and auto terminate cluster of the last step is completed. Yes, I would want to terminate it, and I'm going to go on next. I'm going to keep the defaults for now, and probably I would go with the 3 instances, or for now I just go with the 2 instances. What's the time? So probably I'd go with the 3 instances. Okay, 3 instances. I'll go on next. So the name is be my demo cluster, and the logging would happen in my logs directory. I need to clean up my S3. Oh, where is my logs directory? That's weird. Should be there. There you are. Here's the one. So this should be my logs directory. I select it, and yeah, keep everything to normal. Proceed. For now, you will not be able to do access to this cluster to you. I don't want to SSH, and I'm just going to go with the defaults. I'm going to create the cluster. All right. So this will probably take a while till the cluster is formed and the job runs. All right. So I'll be pausing the video for now. Okay. So let me just show the configuration that's happening. So it's provisioning the cluster with the one master and 3 cores. All right. And here's the steps that I'm given. So my demo jar would be running, and these are the logs that would be coming. So I'm gonna I'm gonna pause the video and continue with the video once the job is probably in the midway, and yeah, proceed from there. All right. So here is the status of the new job that is started, and so as you can see, the job is currently running, and it's running since 7 minutes, and there are around 49 total tasks, out of which 5 are completed and 21 are running, and there are 23 tasks that are pending. Right. So this is the cluster of mine which is currently running, and now here are the logs. There's around 40% of the job that's done. Right. So I would probably be um, showing the output of the file once the job is completely done. Let me go into the EMR and see the status of the task, or rather the job. So the cluster is running, and here is the status of the entire hardware that's running. So there are 3 core instances, and 1 master node, and 3 core nodes that are running on the EMR, right? So yep, that's the status. Hopefully it completes successfully, and post that I'll try visualizing it. And now this is a log URL where the logs are being stored. So this is causing an issue on Firefox. I would rather open it on the Chrome. Yep, so it's still 40%. Let's take it from there. And now as you can see, the number of splits over here is 38. So yeah, I'll probably pause the video now, start the video back again now once the job is completed, and post that I'll visualize the results. All right, so the job is completed, and so the bytes are returned onto the output file, and it approximately took around 14 minutes for the job to complete with 3 instances. So let's go on and see the output file on the S3, right? So I had my, let me refresh my S3 and see there has to be some output folder where, yeah, here's the output folder, and there you go. These are the individual reducers that ran, and these are the outputs from the individual reducers, right? So overwrite it. I would rather open it in the text edit just to view the output files, right? So edit with text edit. So as you can see here, so this is one of the output of one of the files where that's proper. So as you can see, the output of the register is this. The key would be the author, individual author, or the pair of authors, or the co-authors who have published the paper, and the number of papers that they have published. So over here, Anastasios Theropoulos individually has 101 publications, or rather entries in the database alone, right? And similarly, Mitchell D. Thieves has 23, Ori Ulson has 1, Ori E. Ulson. So there were 2 instances of Ori Ulson, so this is the another instance of it. And Brian D. Zebart has 58. So let's open the other output. Okay, I would have to do edit, text edit. Yep, so here is the output of another reducer. So this is pretty self-explanatory. Bhaskar Dasgupta initially has 142 publications, and accordingly Natalia Parde has 15, Tanya Weiber has 83, and Uri Wilson and Philip SU has 4. So I would not want to open all the reducers. Let me open another one, and yep, so here's the other output of it. So I've written a small program in Scala to visualize the entire output. So essentially there's this graph visualization tool that I've written in Scala using GraphViz library. So all I have to do for the sake of demonstration, I would download the output file, the entire output file, and pass the directory name. So let me download this output file. Download to, it would go into downloads as output. It's downloading and it's overwriting, and yeah, so let me open the downloads. So I'll copy the path, and I'm going to give the path of the output file as the input to this program that would eventually visualize, right? So essentially this code, what it does is it iterates into the directory over all the files, and processes the files, and produces a dot mapping, right? So it produces a dot file which is given to the Graphis library to process and produce a PNG um, visualization of the entire graph, okay, or rather the entire output. So let me run. Hopefully there are no errors and hopefully it runs. So I'm gonna run the visualization. I'm storing the output in the my output file name. So this should scan through the entire file, identify the authors, and there you go, it's running. And hopefully it it ran and it has got the output and there are no errors. Let's see how it goes. I'll open the directory in the finder. Open the pi output png file. Yup, there you go. So here is the entire summary of the entire dblp xml file in the form of a graph. So this is the friendship graph, which apparently was the motive of the project. So the nodes represent individual authors, or rather the individual professors, and the weight in each node represents their individual contributions to the publications, and the edges between these nodes represent the co-authors or the co-publications that happen between these two, let's say, professors or authors. So for example, Philip SU, which apparently is the, I think, the largest number of publications done by the author. So there are around 1,241 publications done by Philip SU, and similarly, Bing Liu has 175 publications of his own. And as you can see, this edge that represents over here uh, is the friendship graph that is between Bing Liu and Philip S. Liu, and the weight of the edge represents that they have published 6 papers or publications together, right? So similarly, these are the individual professors who don't have friendship with other professors in the faculty per se, but then they have their own publications, probably with other PhD students or other professors from other university, but not from the faculty of CS department of UIC, right? So yep, that's about it, and this is the entire output of the project 2. So here's the nutshell friendship graph, and here is my job that apparently ran on the EMR, and it should have been terminated by now, and it is terminating. So let me go to clusters. Yes, it is terminated, right? So yeah, finally, oh, a much awaited moment. I'm signing off this video and it is done. So adios.